Good morning, good evening, good afternoon, everyone who's joining our webinar today. The topic today is geospatial analysis with Python for data scientists. And this is an introductory session, and it's the first part in a series of 6 webinars. So let's start with a brief introduction in which I'm going to answer the following questions. First of all, what is the scope of the series? Then why does geospatial matter? Who are we and why are we doing this webinar series? And what do we assume about you, the audience? And then we're going to move to the main part in which we're going to introduce the concept of geospatial analysis versus cartography, and then Python geospatial ecosystem. All right, so in this series, like I said before, it's going to be a 6-part series. Today is the first one, which is an introduction into geospatial analysis with Python for data scientists. The second part is going to be a deep dive into the Python GeoPandas built-in dependencies. In the third part, we're going to demonstrate how you can visualize geospatial data in Python. In the fourth part, we're going to show how you can wrangle data, geospatial data in Python. And then in the fifth part, we're going to work with geospatial data at scale, specifically Amazon AWS. And then in the sixth part, we're going to discuss geospatial data in the context of machine learning. And this series is going to have a bi-weekly cadence. So this first session is on January the 17th, and the second session is going to be on January the 31st. And all the materials that we're going to share in those webinars are going to be available on GitLab, YouTube, and on Medium. All right, so why does geospatial matter? In 2009, a documentary series was released with the name Geospatial Revolution. You can find that series on YouTube. And in this series, Adina Schutzberg, who currently works as a MOOC program manager at Esri, MOOC stands for Massive Open Online Courses, she was quoted with the following: virtually all the information that you are sharing with anybody these days has some kind of geospatial tag on it. Now, the question is, if you ask the same question again, fast forward 10 years in 2019, why does geospatial matter? What would be the answer? What would be different, or what would be possibly the same? Now, 2019, every single event on Earth, whether man-made or not, is a potential data point with a geospatial tag on it. And with that said, geospatial is probably the royal discipline of data science. Now, who is hosting this webinar series? This webinar series is brought to you by TSystems, and TSystems is Deutsche Telekom's business customer subsidiary. And Deutsche Telekom, for those who don't know the company, is one of the largest telecom companies on Earth. Specifically, it's the TSystems Managed Public Cloud Service Unit, which is presenting this webinar series. And the team behind this effort is Stefan Zosel, who's head of sales and marketing, Lars-Simon Zehnder, who is senior manager data science at TSystems. And my name is Rafael Knuth. I'm the CEO of Knuth, a data science consultancy. And on our team is Arnuld Uttre, who is in charge of data science projects with TSystems. All right, how do our customers view geospatial? Now, we are observing that geospatial is becoming a mission-critical discipline. And as an example, if you look into the automotive industry, virtually every single car manufacturer is becoming an all-encompassing mobility provider. So in the past, a car manufacturer was primarily manufacturing and selling cars. So a customer would show up either in the dealership or in the factory, would pick up his car, and he would come back 5 or 7 years later. Now, this business model is being fundamentally disrupted by the customer's expectation that mobility providers should essentially provide mobility across different vehicles. This can be a car tomorrow, or an bicycle tomorrow, or public transportation, or a mix of the aforementioned. So with that, the automotive industry is facing massive customer engagement, which creates vast amounts of geospatial data. So entire line of businesses needs to acquire geospatial analytical skills. And we see this pattern not only in the automotive industry, but in many others, such as, for example, manufacturing, logistic, defense, or in the public sector. Now, what problem are we addressing with this webinar series? So William Gibson once said, it's already arrived. It's just not evenly distributed yet. And to a certain extent, that applies to the geospatial community. So the geospatial community by itself is well established over the last 200 years or so. However, their expertise is not evenly distributed, and the demand is rising. Data scientists and data analysts alike lack education on the subject of geospatial, and the community faces shortage of user content. So, for example, if you look into content on Python geospatial libraries, you will quickly realize that there's not that much content available on this subject. So our goal is to serve our internal audience at TSystems and Deutsche Telekom, as well as customers and the broader data science community by providing relevant, technical, user-centric geospatial content. Now, what do we assume about you, the audience? So our first assumption is that you have at least some exposure to the enterprise world, and with that, you have some firsthand experience with the realms, the pains, and also the opportunities that you have at hand in the corporate world. Furthermore, we are assuming that you're either a GIS expert. GIS stands for Geographic Information System. I'm going to explain the terminology later in this webinar today. You might also be a data scientist, a data analyst, or a BI analyst interested in geospatial. In case you are a data analyst or a BI analyst, it's assumed that you might be an advanced spreadsheet user, and ideally someone who's eyeing to learn coding. So if that's the case, there's a wealth of MOOCs, massive open online courses out there in which you can learn the basics of programming languages such as Python. As an example, codecademy.com. If you are a data scientist, you might already have some exposure to Python and experience with that programming language. And you should be familiar with the main libraries such as, for example, NumPy, Pandas, or Matplotlib. Last but not least, you should be comfortable using Anaconda. And if you have never heard of Anaconda, then please go to this website here, www.anaconda.com/download. Download Anaconda, read the documentation, and just familiarize yourself with this distribution. Consider this webinar series a collaborative effort for users by users. So in case you are a GIS expert, you might want to contribute to this webinar series by joining us as a guest, for example. And if you are a data scientist, a data analyst, or a BI analyst interested in the subject of geospatial, you might have questions or specific requests regarding what topics you're interested in for the forthcoming series. So just let us know, and let's keep in touch, and let's engage with each other, and let's help each other to explore the space of GIS. Okay, so let's talk about cartography and geospatial. So if you look at this picture here, what do you see? When I first saw this picture, it looked very much to me like a cat walking on a carpet. And I showed it to a couple of friends and I said, yeah, it looks like a cat, but it actually doesn't have a tail. And the thing underneath it, it also looks like a carpet. But in fact, this is actually the oldest map found to date, and it was created approximately 7000 BC. And this map depicts an explosive summit eruption of the Hassan Dagi Twin Peaks volcano, located approximately 130 kilometers northeast of Catalhuyuk, and a bird's eye view of a town plan in the foreground. So said Axel Schmidt, archaeologist. And you can read the full story on this discovery on the Smithsonian Magazine. And this discovery was made in Turkey, so I'm not 100% sure whether I pronounced the names of the locations properly. One important concept to highlight here is that in the pre-electronic era, there was no separation between data and the visual representation of it. So you have to memorize this. This is going to be important later once we move on to GIS. So the map was the database itself. And if the map was gone, so was the data. Now, what is geospatial? Geospatial data and information, or GIS in short, is also referred to as Geographic Information System, which is designed to capture, manipulate, store, analyze, and manage data. Due to Wikipedia, geographic data and information are defined in the ISO TC 211 series of standards as data and information having an implicit or explicit association with a location relative to Earth. Now, what are the differences, or what are the similarities and the differences between cartography and geospatial analysis? Now, the similarity is that both a cartographic document and a geospatial data and information, they both contain examples of a base map to which additional data can be added. The differences are that there's no limit to the amount of additional data that can be added to a GIS map. And GIS uses analysis, statistics, and increasingly also machine learning to present data in support of particular arguments which a cartographic map cannot do. Now, let's take a look into how the theory that we just discussed, how that applies in practice. The geospatial revolution was started by epidemiology research on the cholera outbreak in Paris in 1832. And it was Charles Pictet, a French economist, statistician, and demographer, who created the first heat map ever representing the cholera outbreak in Paris. And so you can see this map here. And Pictet was able to link cholera outbreak to a particular water source. And the report is available online, unfortunately only in French. So if you speak French, lucky you. And in 1854, this groundbreaking discovery that was made 20 years earlier was confirmed during the cholera outbreak in London. And you can see here a snippet of the map of London on which the pumps are displayed as an X, and the dots indicate deaths. And John Snow was able to link the location of deaths from cholera to proximity to the nearest water pump. And that was the ultimate proof that cholera spreads through drinking water. And so immediate action was taken in order to prevent further causalities. The geospatial revolution was propelled by a technological advancement by photosyncography. Now, this is important to mention because geospatial has been propelled by technology throughout its entire history up until today. So photosyncography, what is that? It's the photographic process developed by Sir Henry James in the mid-19th century. And this method enabled the accurate reproduction of images, manuscript text, and outline engravings. And photosyncography was originally used to create maps during the Ordnance Survey of Great Britain during the 1850s. Let's talk about the godfathers of GIS. The first mention of GIS as a term was made in the 1960s, and there are two groundbreaking books on this subject, which you can purchase on Amazon. So, Mapping Information, the Graphic Display of Quantitative Information by Howard T. Fisher, and Thinking About GIS, Geographic Information System Planning for Managers by Roger Tomlinson. Roger Tomlinson was an English geographer and the primary originator of modern computerized geographic information systems. And Howard T. Fisher was an architect, city planner, and educator. He was the founder of General Houses, Inc., which was a company that was designing, selling, and building prefabricated low-cost houses. And he was also the founder of the Harvard Laboratory for Computer Graphics and Spatial Analysis. Now, why are we discussing this subject in such a depth? Well, we believe that it's important for you, if you're interested in the subject of geospatial, that you not only acquire some punctual knowledge of Python libraries, but that you also understand the context. That's very much like building a house. You can just start digging holes, but then after a while, you're just going to end up having a whole bunch of holes, as opposed to starting with a plan and then accordingly start building your house step by step. If you want to further dive into the subject of geospatial and cartography, the Stree, which is one of the leading companies in the geospatial space, is about to release MOOC, Massive Open Online Course, on those subjects. So you can sign up on their webpage, and the courses, from what I have heard from Stree people, are going to be released around April, May this year. Good, so let's talk about geospatial with Python. But before we do that, let's ask a very fundamental question. Why not use Tableau, Power BI, Qlik, or the other visualization tools? Now, here's a screenshot that I made based on data which I took from Kaggle. This data is representing 9/11 calls in Montgomery County, Philadelphia. And if you're using Power BI as an example, you can load the data in tabular form. You can cleanse the data, you can wrangle the data, and then later on, by simply dragging the data and dropping it onto your graphic, you can visualize it. And then you can tweak it by adding further dimensions and filter to the data. Now, by comparison, what's the advantage of Python over business analytics services? As you can see here, a graphic information system is representing data in layers. And if you're using Python, you have the great advantage of control and customization of each of those layers. And contrary to popular belief, it's actually very easy to use, because you can utilize multiple libraries which are building upon each other for cleansing your data, like NumPy and Pandas. For wrangling data, here you can also use Pandas along with Matplotlib, and for visualizing data with GeoPandas. So to sum up, if you compare the data visualization BI tools with Python, it's not a matter of whether you should one or the other, but which of those serves what purpose. And from our experience, you should use tools such as Microsoft Power BI or Tableau for rapid prototyping. So whenever you want to make a very quick analysis, you want to familiarize yourself with a data set, that's what I do on a regular basis. I just load the data into Power BI. I play around with that just to get a feel for the data. And once I have some rudimentary understanding of the data, then I move on to an in-depth analysis in Anaconda or in TSystems Data Science Workstation. We're going to talk about the TSystems Data Science Workstation in forthcoming sessions. In a nutshell, this is a platform as a service designed specifically for highly regulated large enterprises to perform data analysis and data science work at scale. Now, as I said before, the geospatial ecosystem has been propelled by technological advancement since the very beginnings. And currently, geospatial is being elevated to the next level by automated machine learning, deep learning, and AI. And some of the projects that you might want to look into is the Stanford DAWN project and the MIT probabilistic computing projects, which both aim to democratize AI. Also, the Uber AI lab just recently introduced Pyro, which is a deep probabilistic programming language. And you can also take a look at DataRobot, which is a data science and automated machine learning platform. So there's a lot of technology that you can utilize to explore your data, to explore specifically your geospatial data. All right, let's move on to working with geospatial data in Panda. So like I said in the beginning, you should familiarize yourself with Anaconda. And so once you download Anaconda from the Anaconda webpage, you should proceed as follow. You should remove the default Anaconda repo. It took us ages to figure out why we are not able to properly perform our geospatial analysis. And then we ultimately figure out that there are two troublemakers, which is MKL and BLAS, which are both within the continuum repo. So remove the default Anaconda repo and then install the Conda Forge repo. And along with that, install PySal, GeoPandas, Descartes, Geoplot, Contextly, Folium, and GeoPy. And we're going to discuss about that setup in forthcoming sessions. All right. So now let's move on to our notebook, which is here. And we're going to talk about the library. So this is going to be a very brief introduction. So I'm hoping that you're not going to feel overwhelmed. We're going to discuss each of those libraries in greater detail in the next session on January the 31st. All right, so let me enlarge this view. All right, it took a little bit, but here we go. So I'm hoping that now you can better read. All right, so the Python geospatial ecosystem. So there are many libraries in Python to work with geospatial data. So the different libraries serve different purposes, such as, for example, general usage. Then there are very specific use case specific libraries. And last but not least, there are libraries for building custom libraries. And we have selected a few libraries based on the following criteria. First of all, there has to be a stable release. Secondly, the library has to be relatively new. And thirdly, it has to run on Python 3. So Python 2 is rather old, and even the Python community wants to move towards Python 3 as fast as possible. So if a library is not supporting Python 3, it is likely not well maintained, and bugs will exist for eternity, and we better consider it dead. So our selection of geospatial specific libraries available in Python ecosystem are the following. First of all, obviously GeoPandas. It is a general purpose geospatial library and one of the most stable, if not even the most stable library. Second comes Folium. It's designed specifically to put together Python and Leaflet.js. Think of it as a marriage between Python, data wrangling, and mobile-friendly interactive maps. I personally like using Folium a lot. if I want to just visualize geospatial data, because the graphics are very beautiful and the library is relatively easy to use. However, it is not built specifically for geospatial analysis in mind. So for that purpose, we have GeoPandas. Then we have PyGDAL, and it's a Python implementation of the Geospatial Data Abstraction Library, in short GDAL, a library for reading and writing raster and vector geospatial data formats. So the question might be, what are raster and vector formats? So just like you have doc as a standard for Word documents and HTML as a standard for web pages, raster and vector are two standards for image files. So exemplary raster file formats are JPEG or PNG, and exemplary vector file formats are SVG. And there's a wealth of vector file formats in the geospatial space. And so raster files are pixel-based, while vector files are based on the mathematical formulas. So if you scale or zoom into a raster file, you get a blurry image, but you don't have the same problem with vector images. So they both have their pros and cons, and think of raster images as an art where you can show contrast and brightness in images, whereas vector is a mathematical way of creating images. Next is PySal. It's a library designed for performing spatial analysis, and some libraries are designed for building more usable libraries on top of them, and PySal is one of those. Cartopy is designed for geospatial data processing in order to produce maps and other geospatial data analysis. It's an excellent choice for map projection work. Shapely works on vector image formats, and it does not do geospatial analysis. It just works on the geometry of the data. Fiona is a special purpose library for performing only one task. Fiona is designed to read and write geospatial data files. Since there is a lot of different geospatial data file format, Fiona has really a lot to do. Descartes serves as a bridge between Shapely and Matplotlib, the de facto plotting library of Python. PyProj is built for cartographic transformations between geographic, latitude and longitude, and map projection, X and Y coordinates. It can also transform directly from one map projection coordinate system to another. And coordinates can be given as NumPy arrays, Python arrays, lists, or scalars. And it's specifically optimized for NumPy arrays. Tree has the facility for running sophisticated spatial queries, inserting, deleting, and upgrading information when doing geospatial analysis. Now, the last two libraries are built specifically for lower-level type of programming. And these are very fundamental libraries utilized by nearly the entire geospatial ecosystem. We will not get more into details on these because they are the implementations of different geospatial protocols defined either in the industry or in the open source community. Now, as you see, there's a whole bunch of different libraries that are important to know about when performing geospatial analysis. And as you will see in the forthcoming sessions, it might be overwhelming at the first glance, but they all work together, and there's beautiful logic that applies to how those libraries interact with each other. Now, if you take a look at this map here, which was made in 1845, and you remember what I said in the introduction into geospatial and cartography, there's no separation between data and its representation. Now, this map here shows the traffic congestion on certain routes. So the thicker the line, the more traffic, obviously. Now, let's take a look at a representation, representation of the same area in France between Dijon and Mulhouse. If you take a look at this map, you see only one picture, right? But when you take a look under the hood, which is what we are going to do on January the 31st, you're going to see that this map consists of multiple layers, and each layer serves a different purpose, and each layer has to communicate with the underlying or with the layer above. So that's what all the libraries that we're going to discuss in detail, which we just showed to you briefly, that's what all these libraries in Python do. All right, so I hope that you enjoyed this session. I hope it was informative. Please leave a comment once the video is available on YouTube, or shoot us an email if you have any suggestions, if you have any feedback or comments, or if you would like to participate in further sessions. As I said in the beginning, this series is a collaborative effort. We're making the first step. We are hosting the series, but we are open for participation of GIS experts and data scientists and data analysts alike. So with that, thank you so much and see you in 2 weeks.